Are matrices confusing and boggling your mind?
Yeah.
Well, award-winning mathematician, Professor Morpheus, is here to help.
Wow.
Hello, I'm Professor Morpheus, award-winning mathematician here to teach you about matrices. Matrices, for those of you who don't know, are compact notations that simplify linear equations. Matrices help mathematicians like myself notice similarities, differences, and patterns formed in equations. Today, we'll be learning how to do and how to use these matrices. A matrix in the form we'll be looking at today is a rectangular array of numbers. Our matrix will consist of coefficients and constants from the equations we'll be using. Here's a diagram. The line in this diagram represents the equal signs in the equations. To start off, say we have the linear equations 3x minus 2y equals 4 and 2x plus 3y equals 8. Our matrix will look like this. What we did was we brought down the coefficients and the constants and arranged them into this array. We know that now that we know where matrices come from, we need to understand the parts of them. This part of the matrices is called a row. This part of the matrices is called a column. Since there are 2 rows and 2 columns, this will be called a 2 by 3 matrix. A matrice's dimensions will always be the number of rows by the number of columns, and never the other way around. Now that we've learned the basic concepts of matrices, we're going to teach you a way to use them. We can actually multiply matrices. Matrices correspond to linear transformations. Multiplying 2 matrices is the same thing as composing the corresponding linear transformations. Here's how you do it. Here's 2 matrices. For matrices to be able to multiply, the 2 must have the same number of rows and columns. So, matrix A has 2 columns, and matrix B has 2 rows. If these 2 numbers are different, you can't multiply the matrices. And these 2 numbers show what the final matrices dimensions will be, 3 by 3. To begin the multiplication, we want to multiply the first row in matrix A by the first column in matrix B. So we would do 4 times 3 plus 5 times 1. Then we would move on to the next column and do the same thing. Showing it once again, moving down the line, 4 times 2 plus 5 times 3, and so on. Here is a factor diagram of the 2 multiplied matrices. And here is the simplified diagram and the final product of our equation. This is the end answer. We have a 3 by 3 matrix as predicted.
Do you understand it now?
Hell yeah, I do. Thanks, Professor Morpheus.